Hello everyone, my name is Mohit Agrawal, and in this video we will be checking bubble sort. So let's get into it. I'm going to share my screen. Yeah. So basically what is bubble sort and why do we need to do the sorting? There are always two questions that we should have, what and why. So what is bubble sort? Bubble sort is basically a sorting algorithm. It is also known as sinking sort or exchange sort. It is the simplest sorting algorithm that runs through the list repeatedly, compares adjacent elements, and swap them if they're out of order. So basically, what it means, when we are running a loop, it will keep checking the adjacent elements with each other. Okay, and in simple terms, we can say it will sort a group of data in a particular order. Okay, that is the simplest thing it will do. Okay, it will just keep on checking the adjacent elements and it will swap, and accordingly, it will do the sorting. Okay, and now like why do we need to do this? Why do we need to do the adjacent element things? So the basic idea is when we when working with data, sorting is a common method used for visualizing data in a form that makes it easier to comprehend the story the data is telling. So basically, why do we need to do sorting? That's the first thing. So there's one example here, like as we have seen in this, like in Myntra website or some, like we have the option to sort the data according to the price and or however we want, right? So we have this option. Let's as we can see, let me just zoom it. Okay, so as we can see, we have this option price high to low, low to high. So we can sort these hoodies or the t-shirts that we want to purchase according to our need, right? So basically, a real life example can be an e-commerce website where we as customers will be very much benefited if we can easily find our product with our desired price, size, and brand, etc. Right? So there are like 100 of products, but we want for a particular price, for a particular size, right? So it will be better if we have some sorting options, right? So like this is one of the main reason, like we as developers should know how to sort in the best way. Okay. So yeah. So what are we going to do in bubble sort? It is basically an algorithm. So it will be having step by step process. So what are we going to do? And the main thing is we are checking two adjacent elements and swap them according to ascending or descending order and move forward. So let's say if you want to swap them in ascending order, so we'll just check two adjacent elements. If the next one is smaller, we will swap it and we'll keep doing it. So what will happen in this way? The biggest element will be pushed at the last. And when we will do the loop for second time, the second largest will be pushed to the second last position, and then the third time the third largest will be pushed to the third last. So like this our entire array will be sorted, right? So this is also the reason it is called as bubble sort, because the data bubbles to the top. Okay, and also it is called as sinking sort because what happens, the biggest element is sinking to the last, right? It is also called as exchange sort because we keep on swapping the elements, right? And why are we doing this? I just told you, like by doing this, after every pass, we will have the biggest number at the last position. That is, after first pass, largest number will be at the end. After second pass, the second largest will be at the second last, and so on. We will check one example as well, right? Thus, bubble sort gets its name from the fact that data bubbles to the top of the data set. Bubble sort is alternatively called as sinking sort for the opposite reason, which is that some elements of the data sink to the bottom of the data set, right? Okay, so let's just first visualize and understand. Later we'll code it as well. So let's consider an unsorted array 31542. Now we will sort this array with the help of bubble sort algorithm. So in the first step it is 31542, right? So first 3 and 1 will be compared, the first two elements. So we can see one is smaller, so we'll swap it with simply. So it will become 13542. Okay. And now the let's say the I is here. Let me write it down as well. I is here and J is on 1. Okay. So it is J is like a nested loop. J will be internal loop, right? So we'll keep looping J. I will be here only, and J is on 1. So we swap that, and now J will move forward. So J will go here. So now it will check with that, right? So it will check with the forward element. Okay, so it will check for the forward element. So as we can see 5 and 4 here. So it will be swapped. 5 is bigger than 4. So it will get swapped. 5 is here now. And now J will again move ahead. So it will check with 5 and 2. Again, like 2 is smaller. So we'll swap it again. 5 will move to the last. So with this first pass, when we are iterating the entire array, after the first pass through the entire array, the largest element is at the last. We can see. Okay. Now we will continue for the second pass and third pass. When now we have this array 1, 3, 4, 2, 5. Right. So now we will start this, and here, like we can see for here, it won't change because 3 is bigger. And then on the second time, it will see for when it will go to here. Yeah, when it will go here, it will see 4 is bigger than 2, right? So it will swap. So it will be 1, 3, 2, and 4, 5. So we can see this array is unsorted, but this remaining, because the second largest is gone to the second last position, right? So this is sorted, right? So by this, we can also understand now when we will move forward, we don't need to check for these remaining parts, right? So here we can say the length that we can take is n minus I. Okay, we don't need to iterate through the entire array. Okay, similarly, we can check further. Now here the array is 1, 3, 2, 4, 5. So it is 1, 3, 2, 4, 5. So here it will check J will be first here, then it will go here, right? And it will be 1, 2, 3, 4, 5. So it will be sorted accordingly. Okay. Yeah, and now let's check the time and space complexity about this. The space complexity will be big O of 1, which is constant because no extra space is required. It is called as also known as in-place sorting algorithms because we are not using any extra space. We are sorting in the same array. So that's what is called in-place sorting algorithm. The time complexity is for the best case, it will be big O of n, and for the worst case, it will be big O of n square. Okay. The best case will be what? Let's say we have given the sorted array only 1, 2, 3, 4, 5. So in the first swap only we can see in the first pass only we will know it won't be swapping anything, right? But it will go through the entire array. So that's why it will be big O of n. And the worst case will be big O of n square when it will be in the opposite order. Let's say we want to sort it in ascending and the array is given in descending. So it will have to go through each case. So in that case it will be big O of n square. We'll check that as well. We can consider n as number of comparisons, right? Okay, so yeah, we can also come to one conclusion that as the size of the array, that is the input increases, the time complexity will also increase. Okay. Okay, so we can check here for the worst case, it will be opposite 5, 4, 3, 2, 1. Sorry. So let's check for the first case, for the first pass when we will loop for the first time. It is 5, 4, 3, 2, 1. So 5 and 4 will get swapped because 4 is lesser. Now first one 5 is big, so it will be 4, 5, 3, 2, 1. And then again it will move ahead, and in 5 and 3 also it will swap. 5 will move here, and then 5 and 2 again it will swap. 2 will come first, 5 will be moved last. So it will be 4, 3, 2, 1, 5. Right. So here we can see the number of swaps is n minus 1. Right. Let's say 1, 2, 3, 4. Okay. So there are 5 elements and it took 4 times to swap. So n minus 1. Right. And now in the second pass, here we have 4, 3, 2, 1, 5. The array is 4, 3, 2, 1, 5. So J will go here. Let's we can see the first here. So it will be 3, 4, 2, 1, 5. And then here as well, 2 is smaller than 4. So 4 will get swapped again. And then again with 1, it will be smaller. Again, it will get swapped. Right. So here it is n minus 2. And we have 2 elements swapped here. Right. And then we'll go to the third pass. Okay. 3, 2, 1, 4, 5 is the array here. First, it will be 2, 3, 1, 4, 5. 2 will get swapped here. So basically here 5 got at the end, here 4 got at the pushed at the end. Now 3 will get pushed, and then 2, and then 1 will be remaining. Right? We can check. Yeah, so here it took n minus 2, here it will be n minus 3. That is in two comparisons. 3 will first, we will compare with 2, and then it will get compared with 1. So it is 2, 1, 3, 4, 5, right? And now only 2 and 1 will get compared and our array will be sorted. So for the fourth pass, we have 2, 1, 3, 4, 5. First two elements will get compared, 1, 2, 3, 4, 5, and we are sorted. So here it took n minus 4 passes, right? So compare, total comparisons were n minus 1 plus n minus 2 plus n minus 3 plus n minus 4, right? In all these four comparisons here, n minus 1, n minus 2, n minus 3, right? And for the fourth pass, it was n minus 4. So we'll just add all of them. It will be 4n minus, and this is like a series, right? 1 plus 2 plus 3 plus 4 plus 5, so on. If the input increases, thus this will also increase. So to generalize this, we have this formula n into n plus 1 by 2, right? So if we calculate it, it will become 8n minus n square minus n by 2. So here we will ignore all the least dominating factors. Only n square will be considered here, the most dominating one. The others will be ignored. Thus the time complexity will be big O of n square. Okay. Yeah, with every pass, the largest element for that pass is at the end and sorted. Next pass, no need to take the loop through entire array. Checking makes no sense. Yeah, that's why we'll take n minus I minus 1. Okay, now let's check the code. Okay, so I have written the code here for bubble sort. Okay, basically there are two loops, nested loops. First is I going from 0 till n minus 1, and then for the next loop for j it is going from 0 and j is less than n minus I minus 1. Okay, basically this will ignore the remaining parts which are getting sorted, the end parts, right? We don't need to go through the entire array. This will be checked here. Okay, and if array of I, array of j is greater than array of j plus 1. Okay, so if the first element is greater than the second one, so it needs to be swapped because it has to go pushed to the end, right? So then we will swap. So we're just taking a temporary variable, we're storing array of j in that, and basically we're just swapping this. Array of j will be array of j plus 1, and array of j plus 1 will be temp, and this will keep on continuing. And after every pass, the first after the first pass, the first largest element will be at the last. After the second pass, second largest will be at the second last. After the third pass, the third largest will be at the third last position, and so on. It will continue, and accordingly our array will be sorted, right? So I've just taken one print array method to print the array. Like I'm just looping it and printing each and every element. And here I've just created one object, this main class. And yeah, I'm just printing the array. Okay. So let's just run and check it. Okay, so sorted array 1, 2, 3, 4, 5. Right, and I have taken the arrays 5, 1, 4, 2, 3. Okay. Okay. So we can even check a bit of dry run as well for this. Okay, so we have this array as 5, 1, 4, 2, 3. Okay. So first, let's I will be here for I equal to 0 and j will be here, right? So we will check. So is 5 greater than 1 according to this condition? Yes, if array of I, if array of j greater than array of j plus 1. So is 5 greater than 1? Yes. So we'll swap it. So it will be 1, 5, 4, 2, 3. Okay. And further it will continue. In the next loop, now j will go ahead. Now we'll check 5 and 4. Yes, 5 is greater. So it will be 1, 4, 5, 2, 3. Okay. And it will keep on continuing. Now it will be checked with 5 will be checked with 2, and then 5 will be checked with 3 as well. So it will become 1, 4, 2, 5, 3. Okay, and again it will be checked, and then it will become 1, 4, 2, 3, 5. Okay, so after the first pass, we got what we wanted. Right. So after the first pass, this 5 is the biggest element is at the end. Okay. We can continue checking. Now then loop will increase, and then for the second pass, we will have 1 will be like that only. 4 will get checked with to the so for the first loop it will be same, and then it will become 1, 2, 4, 5, 4, 3, and 5. Right. And then in the next loop, it will go 1, 2, and then it will check 4 and 3. So is 4 greater than 3? Yes. So it will be swapped. It will become 1, 2, 3, 4, and 5. So it will be sorted here. Okay. Okay. So yeah, that was all about bubble sort. Yeah. Thank you so much.